Okay, so this is question 1 from the practice test. And it says, evaluate the function f of y equals 3y minus 14 at the indicated values. Find f of y plus 3. So what this notation means is that everywhere I see a y, I'm going to change that y to y plus 3. So let's write that out. F of y plus 3 would be 3 times y plus 3 minus 14. And then I'm going to simplify using the distributive property to get 3y plus 9 minus 14 and combine like terms. 9 minus 14 would be a minus 5. Then the next part says f of y plus h. So everywhere I see that y, I'm going to change it to the y plus h. So that would give me 3 times y plus h minus 14. I'll use the distributive property to get 3y plus 3h minus 14, but this time we don't have any like terms, so I would leave the answer like that. Okay, on this one it says, find the domain and range of the relation, then determine whether the relation represents a function. On the picture here, you've got these 4 individual dots, and we're going to use a comma to separate our answers. Because we have these individual dots, the domain will be just individual x's. We're not going to use interval notation for this, because interval notation is used when you have like a straight line or a curve. And there you would want to choose a starting and stopping point so that you could cover all the x's from the start to the stop. So on this one, you're just going to use these individual values of 0. This has an x value of 0, x value of 1, x value of 2, x value of 4. I'm sorry, that's a 5 on that last one. And then for the range, you're going to do the same thing. Since we have individual points, all of these individual points have the same y value of 2. Okay, on this one, it says classify the given function as polynomial, rational, or root, and then find the domain. So we've already got it marked as rational, and it is rational because it's got a variable in the denominator. To find the domain, we're going to take the denominator and we're going to set it equal to 0. Now the reason why we're setting it equal to 0 is because having a 0 in the denominator is undefined. And that would mean that if it's undefined, then it can't be in the domain. So we're going to take whatever expression is in the denominator, we're going to set it equal to 0 and solve that equation to figure out what values we need to exclude from the domain, because those values cause the domain to equal 0. So with this one, it's a polynomial function that I'm solving here. Just to be clear, this equation, or sorry, this expression is rational, but this equation is polynomial. Just the denominator's polynomial. And I'm going to solve this by factoring. I can factor out the t, and then that gives me t squared minus 6t minus 7. I can factor this quadratic a little bit more. T and t, 7 and 1, with a minus on the 7 and the plus on the 1. And then you can set each factor equal to 0. So t equals 0, t minus 7 equals 0, t plus 1 equals 0. T equals 0 is already solved. We've got t equals 7, t equals negative 1. And these are the values that I'm going to exclude from the domain. So I'm going to draw a number line. And I want to exclude a negative 1, a 0, and a 7. But I'm going to include everything else on the number line, so I'm shading everything else. Each one of these sections need to be written in interval notation. So the first section has a lower bound that would start at negative infinity and would stop when we get to that open circle that I've drawn, that value that we're going to exclude. Then the next one is going to start at negative 1 to 0. The next one goes from 0 to 7. And the last one goes from 7 to infinity. So this is going to be our domain. Our domain is every real number except for negative 1, 0, and 7. And this is how we write that in interval notation. For this one, we're asked to find the domain and range of this graph. This is different from the other one because instead of just having individual points, we have a curve, a line. So we're going to use interval notation this time to find the domain so that we don't miss any of these points that are in the middle that are not marked on the screen here. And the strategy that I use for finding domain and range from a graph is to hold a pencil, in this case a ruler, vertically. And for domain, we hold it vertically and go from left to right. And I'm going to think about when is the first time that ruler hits the graph. So my domain is going to start at this x value of negative 9. Now that point, the negative 9, is an open circle, which means that that point is not part of the graph. So I'm going to use a parenthesis next to that negative 9 to make sure that I'm not counting that point in the domain. So that was the, sorry, just a second. My ruler's having trouble. So I'm moving that ruler from left to right, that's smallest x value to largest x value, and I'm thinking about when the ruler first hits the graph and when it last hits the graph. The last time it hits the graph will be at this point right here, which has an x value of 4. So that's when my domain ends, and you can see that this point has a filled in circle, which means it's part of the graph, and that 4 will be part of the domain. So I want to use brackets to indicate that it's part of the domain. So our domain goes from negative 9 to 4. Okay, let me move my ruler to go horizontally because now I'm going to find the range. And with the range, I'm going to go from bottom to top, thinking about the first time I hit the graph and the last time I hit the graph. Bottom to top means you're going smallest to largest. So first time I hit the graph would be at that point right there. Range are the y values. So that y value is negative 9. And just like last time, that point is an open circle. So it's not part of the graph. I'm not going to include it. And I indicate that with a parenthesis next to the -9. Then the last time I hit the graph will be up here at a y value of 7. And since that point is filled in, that 7 is part of the range, and I'll put a bracket on that value. So the range is from -9 to 7 with a bracket on the 7.